So we've talked about a sarcomere. Now we're going to talk about a motor unit. And a lot of this should be reviewed, but I just want to make sure that we're all on the same page here. So we're going to talk about a motor unit. We're going to talk about how a motor unit and a muscle are related, talk a little bit about the all or none principle, and then ultimately what determines the strength of contraction. So what is a motor unit? You've all probably seen this picture before or something similar. Okay, a motor unit is one neuron and multiple muscle fibers. So as you can see here, we have two motor units. We've got the purple one and the red one. I'm not sure why it's so fuzzy, but it is. Okay, and so as you can tell from this picture, a single muscle will be composed of multiple motor units. And while we'll talk about it later this week with muscle fibers and motor unit types, a single muscle will be made up of many different types of motor units, meaning you're going to have motor units within the same muscle that are type 1, and you're going to have some that are type 2. Depending on the type of muscle, that will give you an idea, or certain types of muscle will have more type 1 motor units, certain types of muscle will have more type 2 motor units. Okay, now when it comes to these fibers or these motor units, type 1 fibers, okay, the aerobic ones, they have small motor units. So they don't innervate as many muscles. The neurons themselves are smaller. And then type 2, it's the opposite. They have big neurons and lots of muscle fibers generate lots of force. Okay, now we've got the all or none principle, and it relates to an action potential. It's kind of the same thing. And so basically what the all or none principle is saying is that if a motor neuron reaches threshold, it's going to have an action potential, and that action potential is ultimately going to activate multiple muscle fibers. When these muscle fibers are activated, they fire maximally. Okay, so muscle fibers always contract maximally. They give their all. All right, doesn't matter the size, small or big, they're given everything that they've got. Now, if we have a muscle contraction, we're talking about a whole muscle, not muscle fibers. If I'm having a maximal muscle contraction, all of my motor units need to fire. And we'll talk about this a little later in this unit, but it's actually very, very, very difficult, maybe even impossible, for you to actually activate all of your motor units in a given muscle. We can do this with like outside stimulation, with like electrical stimulation, but you yourself are likely never going to be able to fully contract or fully activate one of your own muscles. Now, we have muscle. One of its jobs, or its main job, is to cause contraction. Well, the strength of contraction can be affected or is affected by several things. One, how many motor units are recruited. So if you've got 10 motor units in your muscle and you only activate 2 of them, well, then you're definitely not going to be contracting maximally. The fibers themselves will be, the ones that are activated, but the muscle itself will not be generating the greatest strength of contraction. The number of muscle fibers in each motor unit. So if you have more muscle fibers, you're likely going to generate more force than a motor unit that has fewer fibers. And then how often is this the stimulus occurring? If it occurs rapidly and in quick succession, that will actually cause the contraction to be stronger. Okay, and so we'll talk about this a little bit later. But even though a motor or a muscle fiber contracts maximally, if we stimulate it quite frequently, it will actually generate a greater force. Okay, and so kind of the way that this works is more motor units that are recruited equal more muscle fibers being recruited. That means we've got larger numbers of cross bridges being formed. More cross bridges equal more force equals a stronger contraction. Okay, and then we can also look at it as stimulus frequency. Okay, increased stimulus frequency causes an increase in calcium release. If we have more calcium, we have more cross bridges. If we have more cross bridges, we have more force. If we have more force, we have a stronger contraction. Okay, and so there are some things that can alter this. And by this, I mean how strong the actual contraction is. But when it's stimulated, when a muscle fiber is stimulated, it's giving everything that it's got. But there are other factors that we can alter that can determine what all that it's got actually means, right? So we're going to talk about how the length of a muscle, the frequency of stimulation, those sorts of things can actually affect how strong or how great the contraction is. It's also important to know, like I said, other factors can affect this that we will discuss later in this unit.